Thank you so much for joining us. Welcome to our webinar on building resilient architectures with LINBIT SDS and Oracle Virtualization. Today we're going to explore how LINBIT software-defined storage combined with the cost-effective, high-performance Oracle Virtualization platform can help you create an open, resilient virtualization and storage solution stack. While both of these technologies shine on their own, the combination of the two provides a flexible, reliable, and redundant alternative of your legacy virtualization solution. First up, we're starting with the Oracle team. We have Senior Principal Technical Product Manager, Marcos Sungaila from the OLVM team, and he is going to dive a bit deeper into Oracle virtualization and all of the recent market changes in the virtualization landscape recently. So the floor is yours, Marcos. Take it away.
Thanks, Ryan, for the introduction. So let's get started. Well, reimagine virtualization with Oracle Linux, Oracle Virtualization. Oracle Virtualization is an alternative to VMware. I am Marcos Sungaila, Technical Product Manager for the Oracle Virtualization product, and I would like to provide you with an overview of the market conditions we see. Broadcom's acquisition of VMware in November 2023 introduced a number of structural license changes in the server virtualization market. The company transitioned VMware's license model from perpetual license to annual subscriptions and adopted a per-core pricing structure. It also restructured the product lineup, consolidating offerings into two main bundles, VMware Foundation and VMware Cloud Foundation. Changes were made across the sales operations and partner programs too, and some adjustments to product roadmaps and development strategies were introduced. As a result, some long-time partners and enterprise customers are reassessing their use of VMware products, exploring alternative solutions in response to cost increases and changes in product availability. KVM is being increasingly considered as an alternative hypervisor for various organizations. As an open source solution built into the Linux kernel, KVM supports both on-premise and cloud-based virtualization environments. With nearly 2 decades of presence in the market, it's recognized for its performance efficiency, offering lower overhead and faster application startup. Its scalability has enabled widespread adoption across enterprise on-premise environments, and it also serves as the default hypervisor in several public cloud platforms, including Oracle Cloud Infrastructure. These characteristics position KVM as a well-established and versatile virtualization option for a variety of use cases. Also, Oracle has embraced KVM as its primary hypervisor, seamlessly integrated into Linux distribution to support modern on-premise and multi-cloud virtualization needs. This shift marked a significant move toward open-source, high-performance infrastructure tailored to today's virtualization demands. The Oracle Virtualization Platform is built on a robust open-source foundation and includes 3 key components. First is the management solution, a powerful and user-friendly interface built on a Vert 4.5 project, offering a VMware vCenter-like experience for managed compute networking, storage, and virtual machines. Second is the Oracle Linux KVM hypervisor, known for its stability and tight integrated with Oracle Linux 8, a stable enterprise-grade OS with support through 2029 and extended support to 2032. The third component, the virtual driver, enhances capability for Windows workloads, offering functionality similar to VMware tools. With its comprehensive, open, and supported virtualization stack, Oracle presents a compelling alternative for organizations seeking a flexible, scalable, and feature-proof virtualization solution. Oracle Virtualization delivers a comprehensive and scalable solution for managing on-premise virtual environments. At the heart of the platform is the Manager, a robust administration portal offering real-time visibility and control over KVM hosts, storage domains, and virtual machines with integrated support for a REST API. The solution also enables automation and seamless third-party integrations. Designed for high performance, the manager can oversee over 1,000 KVM hosts and 10,000 virtual machines under a single engine, the administration portal, making it ideal for enterprise-scale deployments. The platform is powered by Oracle Linux KVM, based on the stable and secure Oracle Linux 8.10 release, ensuring reliable performance as a compute hypervisor. Oracle's virtualization stack supports a broad range of guest operating systems, including Oracle Linux, Red Hat Enterprise Linux, Ubuntu, Rocky, Alma Linux, and Windows Server and Desktop editions. This versatility enables organizations to run diverse application workloads within a unified environment. Together, these components form a powerful, flexible, and feature-ready virtualization ecosystem built on open-source innovation and enterprise-grade reliability. The administration portal provides a centralized interface for managing virtual environments. The dashboard displays an overview of configured data centers, clusters, hosts, and virtual machines. In this screenshot, you can see 752 KVM hosts and over 30,000 VMs managed by a single instance. The dashboard landing page also includes alerts and event notifications. The interface supports drill-down capabilities, allowing users to click through any component like virtual machines for further detail. Viewing all configured VMs, you can filter and sort them out or go deeper in details by clicking on a specific instance name. There is a very nice structured workflow that assists users in configuring data centers, clusters, KVM hosts, virtual storage domains, and virtual networks. A left-hand menu gives you complete access to all functionalities available. Designed for usability and scale, the portal serves as the central point for administration of server virtualization resources. Oracle Virtualization includes a comprehensive set of features needed for managing on-premises server virtualization environments. These capabilities align with those found in other platforms and include virtual machine snapshot for backup and templating, live migration of running VMs between hosts, and automated workload balancing across clusters based on resource utilization. While terminology may differ from VMware, such as live migration in Oracle versus vMotion in VMware, the functional parity is maintained. Additional features include storage live migration, high availability, disaster recovery, scheduling policies, and role-based access control. These components have been confirmed by customers' validations through proofs of concept and real-world deployments, indicating the platform applicability is varied enterprise settings. Oracle Virtualization is positioning as a viable alternative for organizations evaluating virtualization platforms. Beyond offering standard virtualization capability, it's built on an open source foundation with no direct license cost involved. Support is available through the Oracle Linux Premier Plus contract, which provides access to technical systems, documentation, and advanced technologies, such as keysplice for live kernel patching. This support model is often cited by customers as more cost-effective than current bundle offerings from other vendors. For organizations considering migration, Oracle provides open-source tools like PortV2V to assist in transferring workloads from VMware to Oracle Virtualization. Additional partner tools offer features like live migration between VMware and Oracle Virtualization, and a dedicated Oracle professional services team are also available to facilitate these transitions. These options offer flexible pathways for adopting Oracle Virtualization in enterprise environments. Oracle Virtualization is supported by an established ecosystem that includes a comprehensive certification framework. This encompasses application-level certifications developed in collaboration with Oracle's internal teams such as database and middleware groups, as well as hardware-level certifications conducted with leading x86 server vendors. This partnership ensures the platform is compatible and tested across a broad range of workloads and infrastructure. This enables us access to new firmware or drivers for which we have completed certification. The solution is positioned as a universal platform, capable of running a wide variety of applications on supported guest operating systems. In addition to internal integrations, Oracle has established relationships with independent software vendors and partners to provide certified solutions and facilitate advanced virtualization capabilities. Oracle Virtualization is built on an open infrastructure, offering documented and supported APIs and interfaces that enable integration with a range of third-party technologies. The platform focuses on core server virtualization functionality while collaborating with partners to extend its capabilities. Through the use of open REST APIs, partners integrate their solutions to enhance operation workflows. This includes support for virtual machine snapshots, backup, storage, and configuration tools at all. Partnerships also facilitate migration tools for transitioning from other platforms like VMware. Among current technology collaborators, LINBIT provides virtual SAN-like functionality integrated through a formal partnership. Oracle's ecosystem-driven approach is designed to accommodate broader data center requirements via cooperation with best-in-breed technology providers, and LINBIT is one of those. At this time, I would like to hand over the session to Ryan to delve deeper into what a LINBIT solution is and how it integrates with Oracle Virtualization. So, all yours, Ryan.
Hey guys, the first person who was on mute. Thank you for that information, Marcos. That was a great overview there. I just wanted to send out a quick reminder that you can put questions in the Q&A section as the speakers are going. And now we're going to move over to the LINBIT team, my team. We have LINBIT founder and CEO, Philip Reisner, who is going to present some slides on LINBIT, our software, and how we integrate with OLVM. Fun fact, for those that are familiar, Phil is the original creator of DRBD, so I always like to throw that out there when I can. Take it away, Phil.
Thank you, Ryan. So let's get me started with sharing the slide deck. And here we go. So about using LINBIT SDS with OLVM. Before I start into the topic, let me state what we are solving here. So our part is that you have a number of physical nodes containing physical storage devices, and this software turns that into a highly available cloud storage for your virtual machine images and ISO images, etc. So I'm doing a top-down approach today, and the topmost software component is called LINSTOR. And let's start here with an overview from the architectural point of view. So the LINSTOR software is a distributed system. It comes with two main components. One is the LINSTOR satellite that runs on every node of the cluster. It's configurationless, stateless. You install it, that's it. The other part is the LINSTOR controller that is stateful. So you have one instance of that running per cluster, and it has failover locations. The controller offers a REST API, and the controller reaches out to its satellites to do things there. And on top of the REST API, we have a command line interface, a GUI, and the whole system interacts with OLVM either as presenting an iSCSI target or being integrated more natively using a technology called Cinder or CinderLib. For smaller systems and for self-hosted engine, you will use the iSCSI part. For bigger installations, CinderLib makes a lot of more sense. Then let's go into the examples. So to explain how all this works, I'm looking at a sample cluster of 6 nodes, and each of those nodes has enough CPU and memory to run the actual workload. And it also has built-in storage devices. So might be NVMe drives, might be rotating Rust. When LINSTOR gets a request to create a virtual storage device for a virtual machine, it already knows where the virtual machine will run at first. So what it does is, and we are assuming here that our storage policy is that we want to have 2 replicas for purpose of failure safety, right? So we know the VM will start here, and we create 1 replica at the same node and 1 replica somewhere else for redundancy purpose. So same for the black VM. We have 1 replica here and 1 replica somewhere else. So this layout gives us top performance for all read requests because we can fulfill the read requests locally without creating traffic on the network, without adding additional latency for fulfilling those requests. But of course, VMs might move, right? Maybe it's live migrated to another node where we don't have a copy of the virtual volume. That's no problem. We access the content of the virtual volume over the network, so read requests are now shipped to these nodes. So this node has 2 possible storage nodes to go, so it will like do a load balancing of those read requests. Write requests, it always sends to both concurrently. And compared to the previous layout of the VMs and the storage locations, this is not the optimal layout, right? You can configure LINSTOR that it migrates storage to the compute. That's completely optional, but let's assume we have done it. And this runs here for an extended amount of time. That might be 10 minutes, that might be 24 hours, whatever you configure. And now LINSTOR checks out, okay, I have enough available storage capacity here in this node. So it will create a 3rd replica. It will start the resync of all the data over to this node. And that's all completely transparent to your VM, right? The VM doesn't notice this. And after this resync is complete, it will remove the 3rd replica because the storage policy was just asking for 2 replicas. So I hope this gave you an idea how this works. And I'm doing this top-down approach. Now let me talk a little bit about the low-level component, which forms the data path of the solution. And that's DRBD. And DRBD is a kernel driver, so it's in the Linux kernel. It presents your virtual block devices, def DRBD something, and such a virtual block device switches into primary role in the moment it gets opened. And in this case, it will be opened by the QEMU or KVM process when a virtual machine starts, right? If you would close it, it demotes the secondary, and you can, and a moment later, you can open it somewhere else. Then it will be primary there, and that determines the direction of replication. It can also do multiple physical storage volumes with different properties within a replication group that's called consistency group. So that's very useful if you use it with databases, and the database might have fast storage for its write-ahead log and maybe cost-efficient storage for the table storage. It is not a 2-node technology. It can replicate to multiple nodes concurrently. Each of those replication links can be synchronous or asynchronous. You might switch that at runtime. And it also supports diskless nodes, which might be in primary role. So that means the application, the KVM QEMU process actually accesses it on a node which doesn't have a local replica. So in a way, you can think of it, it is like an iSCSI initiator that's connected to 2 targets concurrently. Now, what happens if something fails? Let's say we have a read request coming down from the VM and it's sent to this storage node, and the storage node crashes before it can fulfill it. Then DRBD on this side would notice that, reissue the read request to the other node, and fulfill it for the KVM process. When the crashed node comes back, it gets automatically reintegrated into the cluster as short resync happens, where this node sends the logs that were changed in the meantime. And now let's look at all that from another point of view. This is here, the orange box is like the operating system kernel, so the Linux kernel. And here we have this usual IO stack. And this is the position where DRBD inserts itself into the IO stack. And so you can see whenever a write comes down this path, DRBD sends it to the secondary node. It gets written there to the storage device. The acknowledgement travels back. And only if DRBD receives the acknowledgement from remote and the completion event from local, it will issue a completion event to the upper layers. What types of applications are our customers running on top of this technology? We see a lot of transaction processing. So all kinds of databases, Oracle database, and the open source databases. We also see it being used a lot for analytic processing, also databases. Sometimes I get the question how this is different from Ceph, right? And the difference is that this solution is really tailor-made for block storage. And with that, it is more efficient and delivers better performance. On the other hand, we don't do object storage, or it's not a distributed file system. So because we're so specialized, we have this in-kernel data path. We have a lot of optimizations in it. We decide in the moment you create a virtual volume on which servers we have the parts, the replicas of the virtual volume. We are building on existing components like DRBD, LVM, CFS, etc. And not only because we're lazy, but because your day two operation teams might be already familiar with some of these technologies, and it's not a huge black box for them. And the whole system is very well suited to be used in a hyperconverged way because it consumes very little CPU and memory resources for what it does and compared to alternative solutions. Here in the slide decks, I have a few pointers to benchmarks we published. So you can find here on our blog those papers. Okay, that's it from my part. Back to you, Ryan.
Awesome. Thank you so much, Phil, for that great information. And next up, we get to see the solution in action. We have Ryan Ronander, a solutions architect on the US team, who's going to show us a demo of Oracle Virtualization and LINBIT SDS in action. So go ahead, Ryan.
Thank you, Ryan. Give me just a second to share my screen here. Okay, got it up and running. Okay, so we're gonna take what Phil talked about and kind of show you how that looks in practice here. We have an Oracle Linux Virtualization cluster, and I'm currently logged into OLVM-0, and that's our standalone engine, the control plane, if you will, for Oracle Linux Virtualization. And we have three virtual hosts defined, OLVM1, 2, and 3. And we're going to pivot into the LINSTOR GUI side of the LINBIT SDS components here. And we can see that we essentially have this mirrored in the same configuration. We have OLVM-0 that is running as just a dedicated controller node. And OLVM1, 2, and 3 are the LINSTOR satellites corresponding to the KVM hosts in the virtualization cluster. So same concept applies. If you have 10 nodes, 100 nodes, etc., you're going to kind of map it one-to-one. So each virtual host is the LINSTOR satellite. We have a couple different, let's see, storage domains defined here. One is titled LINSTOR iSCSI, and that is using a little addition to LINSTOR called LINSTOR Gateway to easily create an iSCSI target. You can easily create multiple targets, multiple LUNs, etc., and NFS shares and VMware Fabrics targets as well. And so that's just a very easy way to get highly available iSCSI. And then I believe, as Phil mentioned, this is also a very convenient way if you're deploying the self-hosted engine to first come in and set up the LINBIT storage, set up your highly available iSCSI target, and then proceed with your OLVM deployment. But it's a bit of an advanced topic for another day. We'll also touch base on the LINSTOR Cinder integration that we have as another storage domain. And we can see that in here we do have a couple different replicated resources here. We can see that this VM data resource that is active and primary on OLVM-1 that's actually serving up our iSCSI. So we have I think a couple different ISO images, VM images running on there. And then we have this Cinder volume here for the managed block storage feature in OLVM. And that is currently active as well. We see that it is currently primary on OLVM-2. And we can see that reflected when we come into the virtual machine overview here. I have a couple of virtual machines defined. VM001 that's running on host 3, that's using the iSCSI backed storage. And then we have VM02, and that's using the Cinder integration that we have. And I believe we can also see that listed in the disks that are currently attached to the VMs there. So we can see that we have 2 different volumes, 2 different storage domains, but all backed by highly available, LINSTOR and DRBD, making that possible. And just to iterate, or I guess illustrate what Phil was describing with failover and how everything is able to, you lose a host, it's really no big deal because you still have all of your data. So we'll go ahead and actually power off, let's see, which host is it? OLVM-1, and that's currently serving as our iSCSI primary. And we have a virtual machine here, and I'll open the console so we can see I've echoed hello world to the console on a running VM instance. And then I will go ahead and power off our current iSCSI host right now. So behind the scenes, I've just force powered off OLVM-1. We should be able to see LINSTOR pick that up pretty fast. And we can see, let me just refresh this. Yeah, I just got to scroll over. So OLVM-2 is able to take over and promote our iSCSI target as active. And behind the scenes, a virtual IP address is kind of passing between the nodes as well. And we can come back and we can see that our virtual machine is still running. We still have our console. We can echo hello world 2. Everything's fine. Like a little blip happened behind the scenes, but your VMs are still up and running. Your iSCSI is still up and running. If your self-hosted engine was deployed, it would still be up and running. Everything failed over seamlessly. Now, the same thing would happen with the CinderLib integration, but let's say you lost the host that the VM was running on top of. Obviously, you would lose that virtual machine instance. It would power off, but you would be able to restart that somewhere else in your cluster because you have at least one other physical copy in the cluster. So similar concept. Yeah, this is just a quick little demo on how LINSTOR can integrate with OLVM. So thanks for watching the screen share, and I'll pass it back to Ryan.
Great work, fellow Ryan. It's great to see the solution in action. So thank you so much for that. Always great when a demo comes together. And with that, we are ready for some Q&A. I'm going to give it a second. If you have any questions, excuse me, please put them into the Q&A box below. And I also wanted to mention that we've covered some great high-level information today on combining Oracle Virtualization and LINBIT software-defined storage. But if you would like to learn more and you have additional technical questions, you want to have technical discussions with either team or even a joint session, please reach out to your Oracle or LINBIT sales rep and we can make that happen. Our teams are currently working really closely together, helping organizations make the switch to Oracle Virtualization and LINBIT, and we're seeing some great success. So we're really excited to continue doing that and spread it amongst the marketplace. So it looks like we have some questions coming in here. Let those file in. And we did have one that was answered. I just wanted to call out, thanks for the question, Pedro, and thanks for the answer, John. He asked about how he can access Oracle Virtualization if he wants to test and evaluate it, and it is freely available. John posted some links to documentation there where it is available, so I just wanted to call that out. But let's go ahead and start with Michael's question here. So Michael's question is, Marcos, you mentioned that through the Oracle Linux Virtualization API or third-party technology that uses it, there are some migration tools, and that implies some ways to migrate away from the VMware platform. Where might someone get started learning about those tools, and is there one or more tool that might be recommended specifically for a VMware migration use case? And then there is one more related question. How does the LINBIT SDS storage solution figure into that migration plan? So I'll let you start that, Marcos, and then maybe if someone from LINBIT wants to join in around migration.
Sure. Thank you, Ryan. The migration process starts by reading all the information that comes from VMware and creating the same counterparts into OLVM. You have two paths to follow. The first one is called the code migration or an offline migration. The source VM must be powered down, and you use tools like virt-v2v from the command line or the OLVM web interface. From the OLVM web interface, you can use the same import proxies as you have from the command line. Two main differences between them. The command line, using the command line, you can add VDDK library from Broadcom that speeds up the transfer for virtual disks really extremely fast, making it really extremely fast. Using the web interface, that integration is not possible. Both of them are offline migration. Power off the VM, source VM, make the importing proxies, run importing proxies, then start it on OLVM side. For the live migration, which is also possible, you have at least two solutions. Both of them are provided by Oracle partners. One is the cloud-based Coriolis, and the other is the Aquare Cloud Motion. Both of them are able to copy all the virtual disks from the remote instance, so it reads everything from VMware, transfer to OLVM, and in the end, you face just a small gap, a small hiccup, pointing off on VMware, pointing up the resulting instance in OLVM. It takes longer than the offline method, but it's completely feasible and it has a extremely reduced downtime. There is an Oracle article in the blogs oracle.com describing how to use the command line importing proxies. We'll share the link later. And back to you, Ryan, if we can answer the next part of the question.
Yes, the last part for the LINBIT team was, how does the LINBIT SDS storage solution figure into that migration workflow?
Okay. Then I take it.
Think so.
I think in the described migration workflows, LINBIT SDS is just active on the OLVM side, and the image gets copied in the migration process. So that's about it.
Just to add to your comment, Philip. Yes, and from my perspective, from the OLVM perspective, it will be the destination storage domain, and we'll receive the new virtual disks that are being uploaded in the migration process. I think that one of the best options here is that the disks will be written locally to the host running the importing process. And then the replication process takes place just to replicate it across other nodes. Am I correct?
Yes, the replication on the LINSTOR side, DRBD side, that is completely transparent. So
Perfect. Thank you
I
both.
think conceptually it's really not going to be much different than creating a new VM with new allocated storage. It's essentially the same thing. It's just you're doing a lab migration as well.
Perfect, perfect. All right, we will check that one off. Thank you so much for the question, Michael. Next, we're going to move on. This one is, I believe, for the LINBIT team, but whoever can chime in. It says, say we had 10 hosts and each had 9 disks participating. How do you guys handle disk failure on one of those hosts? I feel like they're asking about how we would handle local disk failure here.
right. So when you set up the LINBIT storage system, you have to decide about the failure domains regarding physical storage devices. So there is a certain trade-off, right? If you go for a bigger failure domain, in other words, you use all the 9 disks and put them into a single volume group, then you would lose all the replicas on one machine in the moment of a physical disk failure. If you take another trade-off and make that 3 volume groups, then you would just lose a smaller part. But losing a replica, that's not a catastrophe. This is what DRBD and LINSTOR are there for. So when LINSTOR realizes, okay, I lost a volume group on one of my physical machines, it will allocate new replicas on other machines, replicate them again, and restore the configured target replication count you want to have. And that LINSTOR does this automatically is also a policy that's up to you. So what I want to express with that, if you do maintenance on one of your machines, LINSTOR will not immediately kick in and create new replicas just because you do maintenance on machines.
Perfect.
Okay, I hope this answers the question. Sorry.
Thank you so much, Phil. No worries. All right, let's mark that one completed. Next up, we have a question from Angus. Thank you for the question. He said, hi, I think I missed, but is the LINSTOR solution running on the KVM hosts?
Yes. So the LINSTOR solution consists of 2 parts, LINSTOR and LINSTOR, that's the control plane, and DRBD, that's the data plane. And yes, it runs on the KVM hosts. It runs natively on the host kernel, the DRBD part, and the satellite processes run natively on the host machine as processes there.
Perfect. Thank you, Phil. Leandro, I can actually answer this question. The question was, how do you get access to LINBIT SDS to test and evaluate on your OLVM environment? And that is something that I can help with. I'll follow up post-webinar. We do offer free trial accounts to test out our software. Much like John shared in the answer to his question, you can have access to our repositories as well as some access to support while you test. So I will be sure to reach out and get that set up for you post-webinar. So thanks for the question. We just have a few more coming in here. Thank you so much, everyone. Is there a plan to upgrade OLVM to Oracle Linux 9?
I'll take this. And yes, we are working on the upgrade path to Oracle Linux 9. including a seamless upgrade path from Oracle Linux 8 to 9 for KVM hosts. And in the future, the full solution will be running on Oracle Linux 9. Unfortunately, no ETA so far, but we are working that.
Awesome. Thank you, Marcos. And another question here from Angus. What is the minimum number of hosts for the LINSTOR solution?
Yes, the minimum is 3.
That was 3 hosts. Got it. All right, I'll give it another second here. If anybody has a last-minute question, feel free to drop that there. But while I am doing that, I just wanted to say one more thank you to everyone who joined us today. Thank you to all the presenters from the Oracle and the LINBIT teams. We will be sending out a recording of the webinar shortly, as well as following up with all the registrants if there are additional questions or wanting to do POCs, evaluations. We are here to help. Like I said, we're working really closely with the Oracle team. We can have a joint session, and we'd be happy to help answer more questions and see how we can help. Looks like we just have a thank you so much from Angus. So thank you very much, Angus, for that. Thanks for the great questions. And with that, I think we can call it a success. Thanks, everyone.
Thank you.
Thank you.